Hello everyone, welcome to my YouTube channel. Today we are going to see the Maharashtra State Board Class 10 Science 1 Chapter number 9 Carbon Compounds. Carbon compounds are very important component of our daily life. When we talk about the carbon compounds, basically the carbon is present in most of the materials which are naturally occurring. Most of the fuels or almost every fuel contains the carbon because the carbon is nothing but the that kind of element when it's react with the oxygen or when the carbon products are burned, they produce heat along with that. So to understand all this particular concept, and the carbon itself is called as the versatile element, why that also we are going to see under this particular chapter. So to understand that, we have to start with the basic part of the carbon. Carbon symbol is a C, as you know very well, and its atomic number is a 6 and the mass number is a 12. Electronic configuration is a 2 and 4. So when we talk about the carbon and its hydrocarbons, already we have stated in a previous standard. Thus hydrocarbons, they have the low melting and boiling points. You can see over here is about the methane, that is a CH4, is having a minus 183 as a melting point and minus 162 degrees Celsius as a boiling point. Next one is ethanol, that is a CH3 CH2OH, is having a minus 117 degrees Celsius as a melting point and the 78 degree as the boiling point. Chloroform, that is a CHCl3, is having a minus 64 as a melting point and 61 as a boiling point. Acetic acid is a 17 as a melting point and the 118 boiling point. Now here when we talk about the carbons, they have given the basic information over here. The carbon atom, that is a C6, electronic configuration is a 2,4, number of electron in the valence shell is just 4, nearby noble gas and the electronic configurations. So we have a helium and neon, both are the near to it. So helium is having electronic configuration as a 2 and neon is having a 2,8. And when we talk about the carbon compounds, they form the covalent bond. Like here example they have given is about the hydrogen. You can see it's sharing an electron because ionic bonding and the covalent bonding, that already we have stated in a previous standard. Ionic bonds are nothing but what, where the transfer of electron is taking place from the one atom to the another atom, and the charged ions are getting formed, cations and the anions, and they are attracting each other and forming the ionic bond. Whereas in the covalent bonding, there is a share of electron. Two atoms share an electron to complete their triplet or the octet. So here the carbon, when we talk about, it's forming the covalent bonds. Example they have taken over here is of the hydrogen, that is H2, sharing a 1,1 electron and forming the covalent or the single bond between the hydrogen and hydrogen atom. Same way they have shown over here is about the oxygen also, O2, and then the N2, that is a nitrogen gas also. So in oxygen there is 2 electrons are getting shared, and in the nitrogen 3 electrons are getting shared. Further, the double and triple bond, which we call them. Further, what we have under this particular chapter, that is the structure of the methane. The structure of the methane is nothing but what you can see over here. The central is nothing but the carbon, and these are the 4 hydrogens we have. One hydrogen and the carbon, they are sharing a 1 electron. So like that 4 hydrogens are there who are sharing their 1 electron with the carbon atom. And due to that, the hydrogen gains 1 electron and sharing, and its duplet is complete. and one electron from each four hydrogen atoms completes the outermost orbit for the carbon. So that gives a structure of the methane. So this is called as the electron dot structure. This is called as a line structure of the methane molecule. The next what we have to study is a carbon, and why it's called as the versatile element. Now here the model of a methane they have shown, you can see or you can check it out over here how it's look like, ball and stick model, and this is a space filling model. Now why it is called as the versatile element, let's see. Like some other atoms share the valence electron to form covalent bonds. Similarly, we also saw the structure of the simple carbon compound methane, but carbon is different than the other elements. The number of compounds formed from copper is extremely large. It's forming a very large number of the compounds. It's not only like one or two or three, it's making a huge list of the carbon compounds. In that, when we talk about the millions of molecules ranging from the small and a simple methane molecule to the extremely big DNA molecule are made up from carbon. The molecular mass of carbon compound ranges from 10 raised to 12. This means that carbon atom comes together in a large number to form extremely big molecule. What is the cause of this unique property of a carbon? And we call this as the characteristics of the carbon. Further, when we talk about the carbon, it's a unique ability to form a strong covalent bonds with other carbon atoms. This results in a formation of a big molecule, and this property of a carbon is called as the catenation power. It's called as the catenation power, where carbon can get linked with a carbon and form a long chain. Further, when we talk about the carbon compounds, you can see over here the methane CH4 is having a molecular mass of 16, benzene is having a 78, penicillin is having a 334, cellulose is having almost around 10 raised to 5, DNA is having almost around 10 raised to 12 as a molecular mass. So you can see the difference starting from the basic carbon compound, that is a methane 16, till the 10 raised to 12 as a molecular mass. So you can imagine what a huge gap we have and what is a huge list of components or the compounds we have made from the carbon. Further is hydrocarbons, and basic part of this already we have said in a previous standard. Hydrocarbons can be classified as a saturated and unsaturated hydrocarbons. Saturated hydrocarbons where the carbon atoms are linked to each other with a single bond. Whereas when we talk about the unsaturated hydrocarbons, then there will be at least one double or triple bond between carbon atoms. So these things already we have studied in a previous standard. And that double and a triple bond, when we talk about, that comes with the sharing of a 2 or 3 electron between the carbon atoms. Further is a straight chain, branch chain, and the ring of carbon atoms. When we talk about the carbon atoms and the property called as the catenation, when the carbons are connected one after the another in a single straight chain, like here if I want to draw it like carbon, 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 like that, if it is there, then this will be called as a straight chain. But instead of this, suppose if I am having like this way, carbon, 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 and here if I am making a carbon, then carbon, like this if I am making, then this will be under the category of the branched chain. Because you can see over here, if I am following it, this is a one chain and this is the another chain. So we have this, we can consider as a branch of this. And that's why this kind of a structures are called as the branched chains compound. And the next one, that is the ring of carbon atoms. So in this case we will have like this way. Roughly I'm just drawing over here is one of the compounds. So you can see over here I had drawn the 6 carbons and they are forming a one ring like structure. You can see over here they are forming a ring like structure, and that's why this kind of a carbon compounds are called as the ring of carbons. Further, that is they have given over here is about the straight chain of a carbon atoms, structural formula and the molecular formula they have given for the saturated hydrocarbons. So here they have given like this. Only what you have to do is you have to fill the valencies. Like here, if I am writing for the this one C and C, what you have to do is the remaining valencies we have to fill with the hydrogen. So here if you will count it, it is a C2H6. So like that you have to write for the others. So you can take it from this and you can complete this table as a activity for you. So this particular video, this is an activity which you have to complete. After this they have given is about the isomeric compounds. Isomeric compounds and the other things, this all we are going to see in the next video. So this activity, don't forget, complete this activity and post back to me.